Oh, okay. Let me stop the recording. That's the first thing that I want to talk about. I remember in last class I told you guys negative statement. Okay. So I have talked about the statement forms. I've talked about operations on a statement. So first, let me talk about. I've talked about truth values, guys. Did I talk about truth values or not? Can anyone confirm that I have mentioned truth values and operations?
Yes, sir, you did.
Yes.
Okay, cool.
Yes.
Uh, so conditional and biconditional statements are remain. So I'm going to talk about conditional first. So conditional actually means implication. Now, what does it mean? What do you think this is? So when you have a statement P, this implies Q. So let's take an next statement. My car is out of gas. My car won't run. So if I say that P implies Q, this is P and this is Q, what does this mean? This means that when I tell you that, oh, my car is out of gas, you can conclude that my car won't run. But if I tell you that my car won't run is true, does this mean that this is going to be true? It's not. Maybe my car actually has a broken, has a hole in engine, or maybe my car has an issue with wiring. It could be anything, right? So it is very important for you to understand that the statement Q, to make that happen, statement Q true, doesn't mean P should be true, right? So we are going to talk about the truth value right now for conditional. You guys can write down. And we will break them down one by one. So if we have both true, then there is no issue, because if I tell you, okay, my car is out of gas, my car won't run, totally fine. P implies Q is going to be true. Now, if I say that this is true and this is false, what do you think this is going to be? I'm saying my car is out of gas. You know for the fact that when your car is out of gas, your car won't run. That is always going to happen because it's implication. And you are saying that your Q is false here. That means that P implies Q is false, right? Any doubt here, guys?
No, sir.
Okay. Now, I just told you that what if this is false and this is true? What do you think that happened? Think about it. I just said that if you,
True.
yeah, right. I just said it. Why? I just said it that when your car won't run, you don't know why it is not running, right? Maybe your car is not out of gas and it is still not running. Does that mean that P implies Q is false? It's not. Why? Why do you think it's not false? Because your car is not running and you don't know that your antecedent is true or not. So whether your antecedent is true or not, you have no idea why it's not running, but it's not running. I mean, ultimately you're getting the true result. So that's why it's true. Let me repeat that. What did I just say? I just said that what if this is true? Does that mean that this should be true? No, right? Why? Because your car could have some other problems, and because of that, it must not be running. So to think about that, you think that okay, these are the other problems that might be possible. So does that make this implication true? No, because you know for this fact, okay, when I'll be out of gas, my car won't run. That's a true statement. So I don't care about it. That's why it's true. Now, similarly, if this is false and this is false, what do you think the implication could be? Guys,
So true.
yeah, it should be true.
True.
But tell me why it is true. Tell me why this is true.
So in this example, if we take false of P, which is my car is not out of gas, and G, and the false of it is my car will run. So both of them make it true in
Okay,
this example.
just give me 1 minute. Yeah, sorry, Nitik. Can you please repeat?
So basically, in this example, if you take false of P, which is my car has gas, and G is my car will run. So that in that example, it makes it true. But I don't
Why?
get the case
Why?
how define it.
Let me tell you why. So, what did I tell you last time? Law of excluded middle. Do you guys remember? That every statement has two kind of truth value. Either it is going to be false or either it is going to be true. So when you say that my car has gas, hmm, and my car is actually running well, are you talking about that my car has not gas? I mean the negation of the statement. Are you talking about that? So when you are saying that P is false, this is false. Sorry. And this is also false. Q is also false. Is this imply that the truth value of Q is dependent on P? No. You know for this fact that your car won't run when you are out of gas. That is a fact, right? You are not changing that. That is some sort of, I can say the gospel. So it is not going to change. And what does that mean? That means that this is going to be true. So you don't care that whether so many people say that okay, my hypothesis is false and my succession is false, then what would be the implication? It would be true. So many people think in that way, but you need to think about in terms of logic. Then why do you think it's true? So does it talk about P implies Q? That's the question. It's not. It doesn't talk about P implies Q, right? So that's why this is going to be true. If it would have talked about P implies Q, then I would have thought about it. Okay, yeah, it is making sense, but it is not making sense. You know for this fact that your car has gas. You know for the fact that your car is running well. Okay, can you say anything about P implies Q? No, you can't. So can you say that it is false? No, it's not. So law of excluded middle, what does it say? It says that if you can't prove it, that this statement is false, that then it must be true. Last time I did, like last time I proved now key phi statement phi is a subset of every set. So that's how we did it. Law of excluded middle. So law of excluded middle is telling you that if you can't come in that P implies Q is false, then that means that P implies Q must be true. That's what law of excluded middle says, and that's why this is true. So you need to think in terms of logic. Okay, moving on. I'll start with why conditional. Um, or do I need to take one more example? What do you guys think? Have you guys understood this topic conditional? Guys, answer. Guys. Okay, anyone? Do I need to take example?
So I'm okay with this one example, but
Okay.
what about maybe other people?
Yeah, other people.
Sir, I got it as well.
Cool. Cool. So most of you got it. Dilip, Sarvjyoti. Am I pronouncing it right?
Yes, sir. Okay.
Fine, then I'll start with biconditional. So what does biconditional means? It means that P implies Q and Q implies P. Okay. So that is what it means. Now, yeah, so when you write this, combine them, you get this, right? And this is the both ways implication. Now, think about it. What does this mean when you say both way implication? So when you say that I'm thinking about an even number, the Q statement is that I am thinking about a number divisible by 2. What do you think? P and Q implies both ways, right? It does. So if you're thinking about an even number, that ultimately implies that ultimately makes the statement Q true, because you're also thinking of whatever the Q is talking about a number which is divisible by 2, and that is an even number, right? So how do we make the truth table for this? This is your P, this is your Q. P implies Q, Q implies P, and what did I set up? I set up that these two are intersection, or you can say that conjunction. So intersection or conjunction, that would be P biconditional Q, and you make the truth table. It's as simple as that. I'm sure many of you know that would be the result. So this is true, this is true, this is true. Then when you take T, this is F, this is F, this is going to be true, this is going to be F. Can anyone tell me what would be the next one? Okay. So this is your biconditional truth value. Right. Now think about it. When both are true or both are false, you're getting true in your biconditional. When one of them is false, you're getting false. Why do you think that? This is an interesting question, very interesting question. Why do you think when one of the statement is false in biconditional, you get false. Anyone?
So P implies Q, but Q does not imply P. So that's why it cannot be biconditional, right? It has to be that both of them satisfy each other. Or
Yeah, yeah. Who said it?
so Nitik,
Okay. Nitik, um, you're just this margin of the, I mean, you're right actually, but just this portion away from the right approach. So you're on the right track. Okay. First of all, let me tell you. But just one more step. Okay, you need to think about it. Both of them, both implication, both phase the implication should work. That's what you're telling. That's totally fine. But think about in terms of logic. That why do you think that it is making these two implication one side false, then your both ways implication is getting false. And I just said the answer. Okay, come on, no one, because guys, it's the conjunction. You take the conjunction right here. Look at this. Remember, they take here.
yes.
So one of them would be
Yeah, I
false.
know this.
Now you got it, you guys. One of them is going to be false. The whole implication, both ways implication is going to be false, right?
Yes.
Good. Very good. Yeah. So let me talk about uh, non-need tautologies. And you guys don't need. Yeah. So I'll just give you two results. This is really important. Except that there's nothing important. Okay, so these are the results, guys. Contrapositive and uh, biconditional, conditional are logically equivalent. So if you have P implies Q, okay. So what is the contrapositive? The contrapositive is negation of Q implies negation of P. That's contrapositive. And these two are logically equivalent. So when you make the truth table of this one, you will get the same truth table as this one. And you can, I mean, you can do that. It's not a big deal. And what else? Converse and inverse. Converse and inverse are logically equivalent. So when you say that P implies Q, what do you think converse would be? Q implies P. And when you say P implies Q, inverse, negation of P implies negation of Q. So this and this are logically equivalent. So when you will make Q implies P, and when you will make the truth table for negation of P implies negation of Q, will get the same truth values. Now, I want you to think about this in a minute. That why do you think intuitively that this is correct? I mean, why do you think converse and inverse are logically equivalent from your intuition, not the truth table? Forget about it. Anyone? Tell me the answer, Gulfisha. What do you think? Why this is logically equivalent?
Sir, repeat question.
Oh, are you fully aware now?
Yes, sir.
Okay. So I am asking that why do you think converse and inverse are logically equivalent for a conditional?
So not getting.
We're not getting. I am saying that you need to think about this intuitively, that your intuition must tell you that, okay, Q implies P and negation of P implies negation of Q are going to be logically equivalent. That means that the truth table are of course going to be equivalent, but you need to think about them with intuition. What do you think? Anyone can answer that. Guys, I don't know why these basic questions actually make you. So think about the statement the last time I gave you. My car has, if my car is out of gas, my car won't run. Think about that example. Now it's opposite. So you're saying my car won't run. If my car won't run, then I'm out of gas. That's what you're implying. Now think about negation of P implies negation of Q. What would be negation of P implies negation of Q? That you are saying my car, if my car has gas, then my car will run. That's what you're saying. Now think about both of them. Both the statement. The first statement that I made is my car will not run if I am out of gas. And the second statement you are saying that my car, if my car is, if my car has gas, then my car will run. That's what you're saying in the second statement. Why do you think these two are logically equivalent? Okay, no answer. So these two statements or any statement when you in general take and converse, this is your converse and this is your inverse, right? So what are you saying intuitively? You are saying that this is your antecedent, right? And you are making P only true. I mean, this implication is going to be true when P is going to be false. Think about it, right? Otherwise, you can't say that this is going to be false, this implication. So when your P is false, here your P is false, right? Because you have changed this one. So, I mean, you have taken the negation of P. So your whole implication, the implication that this implies is actually going to give you the same result because you're assuming that this particular part is actually false. You're starting with that. You're thinking that, okay, my car has gas. That implies that my car will run. That's what your starting point. That's what you're saying in inverse, right? So converse is always going to be logically equivalent with that. I mean, think about this with another problem. Is like I tell you that, okay, I ate my breakfast, then I'll run 5 kilometers. This is another example. So I ate my I ate my breakfast and I walk 5 kilometers. That's my statement. So what would be the converse? The converse would be that I walk 5 kilometers. If I walk 5 kilometers, then I had my breakfast. Now that's your converse because you changed the statement. You changed the statement while making the converse true. So the implication is that if I walk 5 kilometers, then I had my breakfast. So it is making a strong argument that when you walk 5 kilometers, that means that you had your breakfast, right? You can't say anything other than that. I mean, if you walk 10 kilometers, can you say that you had your breakfast? You can't. It is very specific that I walked 5 kilometers. If I walked 5 kilometers, then I had my breakfast. That's all. That's all you're saying. So it's a very strong argument. Now go to the second part. Second part is inverse. Inverse says that, okay, I didn't have my breakfast. Can you comment on that? You walked 5 kilometers, you walked 10 kilometers, or you walked any kilometer? You can't, because you didn't have any breakfast. And that's the same thing giving you the first one, because that's a strong argument. Okay, I walked 5 kilometers, then I must have had my breakfast. Guys, am I losing you or what? Am I boring you? Just tell me, okay? Are you guys able to understand this intuitively?
Yes, sir.
Who said yes? I don't know. I
Prashant.
mean, okay. Oh, logic is, see, in logic, imagination is really important. Really important. I mean, we will do microeconomic theory and in your first year, and that's where logic is going to come. And a lot of abstract mathematics. That's one of the beautiful mathematics that you're going to see. And that's why I'm teaching you all these things. These things are going to be there. But anyways, if you guys have understood, that's really great. I don't want to use, I mean, otherwise you can get it easily. I mean, you can make the truth table and you can get the result. Okay, these two are logically equivalent. How do you show the logically equivalent? You guys know now. You make the truth table, Q implies P, and you make the truth table for P, negation of P implies negation of Q, and you show them, okay, these two are going to be, so T, T, F, T, 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 F, T. That's what I think you should get when you will write P and Q. Sorry about that. Yeah. T, 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 F, F, T, and F and F. Yeah, that's what you should get. You can compute that. It's up to you. I'm leaving that up to you guys. Yeah, so this is the most important part. I'm going to give you some examples on negation of a statement, because last time I did not complete that part. Okay. So how do you negate a statement? Let me take a very small example. See, my notebook has all the big examples. No, it's not going to work. Okay. So in general, what we do, if you guys remember, we uses two quantifiers. So those who are new, for them, there are two quantifiers. You guys should watch the lectures that's on YouTube, but that's totally okay. For now, you should know that these two are quantifiers. This is a universal quantifier. This is an existential quantifier. And we use them to make our open statement, to make an statement. So open statement are those statements where we use a variable and we don't know about the truth value of statement. So to make them a statement, we use actually these quantifiers to incorporate in our logic and make them a statement. So what do you mean by a statement? I have already said that before, that statements are those sentences for which you can mathematically think about it. Okay, and you can say that, okay, this is going to be definitely true or either definitely false. I mean, any of them, either it is definitely true or it is definitely false. That's when you say that, okay, these things are statement. Now, let me give you an example that if I say that number X and Y are odd, this is a simple statement. Okay. Now, how do you negate this? How do you negate this? So you say that number X is odd and the number, sorry, yeah, the number Y is odd. Okay. Now, this part is one statement, so you write them P, and this part, Y part, is one statement, you write them Q. So what do you think you have? P and Q. So when you negate them, you need to always do that for the sake of making the choosing the right option. In case if you get if any entrance exam or any economics school asks that. So this is going to give you my negation of P or negation of Q, right? So this is a symbol for or. Always remember that. So what is going to happen? What did I just do? I just I'm going to backward. Okay. So what did I just do? I had a statement. I broke them down and I started writing in statement form. So what are P and Q? P and Q are your statement variables. Okay. These are the statement forms, you can say. And these statement forms are combined together with an operation. That operation is AND. This operation is AND. When you combine them, after that, you're taking the negation. Because you're negating that statement, so you take the negation. This negation will give you, because this is an operation, so this negation is giving you negation of P, and is going to convert it into OR, and negation of Q is going to be negation. I mean, you take the negation on Q, you will get negation of Q. Now I have reached at a statement forms. Now I need to write what? I need to write them in terms of English. Okay, again, because that's what we are doing. So the number X is not odd, or the number, sorry, Y is not odd. Guys, now I want you guys to be very, very careful right here. Okay, now you must be thinking, okay, if it is not odd, then it must be even. That's totally fine. I'm not denying the fact. But look at the options. Always look at the options. What are the options? If you find, first of all, can you combine them? You can, but not always you can combine them. So when I said that you can combine them or not, I meant for this line, this. So here X and Y, I mean, here these statements can be written as the number X or Y is not odd. Do you think this is the same statement as this one? How many of you think that this is the same statement as the above that I have written? And let me write one more. Meanwhile, you guys think.
It's the same.
Why do you think it's same?
So the first and second statement are just, I mean, you have just reduced them grammatically, and thus the third one is a logical implication that not odd means even.
Right, right. What's your name? Sorry, I'm not able to see anyone.
So Nitik here.
Oh, right, Nitik, yeah, always on time.
Nitigya.
Very good. Good. So these two are same. But my question is that can you do this every time? Can you combine them always? That's also a question. These three are equivalent. So that's very good. What you said that I have made a logical implication that not odd would imply even because you have just one option, either odd or even. So that's totally fine. Here you can do that. But can you always do that? That's my question. Think about it.
So yes, I think we can do that. Uh, I did not really understand it with this example, but I was thinking about it in another way.
No, we can't. Let me give you an example. I'm thinking one. No, you can't. So let's think about, yeah, Nitigya, right? So see, I'm saying that Nitigya is feeling cold. Okay. Yeah, Nitigya is feeling cold. What else? Tired and hungry. How many statements are here? There are three.
No, it cannot be done with three statements, I think,
No, it's
because
not
we
about
have
that. No,
numerous
no.
options.
Again, listen. It's not because you can't do it, the logical implication, or you can't just do this combination. I mean, the combination that I'm talking about, like here I have combined. You can't do that all of it. That's what I'm saying, even with two statements. So even if I say right here, I mean, you remove tired part, you remove it. So you have just two part. Okay, just let it go with two part. Nitigya is feeling cold and Nitigya is hungry. Okay. Now you must be thinking, why didn't I use the word feeling? Why? Think. It will take time. Guys, I'm not teaching one person, I'm teaching, come on, you guys should answer. This is really basic question. Why do you think that I haven't added this particular verb here? It's not an English course, it's a logic course. Come on. Logically think about it. Why? Jharna, why do you think? Jharna, is she here?
Yes, sir, I'm here.
Yeah, so you're at loss. What is happening?
I'm not getting the question.
I'm saying that why haven't I included this word in this statement when I just, decompose this whole statement, the above statement? You need to negate this.
Because feeling cold is one statement and hungry is one statement.
That's all you need. Okay, that's simple, common sense. That's very good. So now, if you take the negation of this one, what would you get? Nitigya is not feeling cold. Can you say right now? Now, or Nitigya is not hungry. Now, this is the question, very interesting question. Okay, and I want all of you guys to think like the way I did here, that not odd implies even here. Okay, look at this. can you say right now that not filling code can I convert this not filling code into Nitya? It's a long name, man. Is hot, feeling hot, or warm? Can I say that? Can I say that, guys? Guys, what happened? Are you guys bored?
Do we only have two options? Like
No.
cold and hungry. Sorry,
Yeah.
cold and
Yeah.
warm.
Guys, listen again. This is the statement that you had, and you wanted to negate this. What is the first step that you take for any statement? You decompose them. You decompose them into
Oh,
statement
sorry,
forms.
sorry.
So yeah, so this is your P, this is your Q. Now you take the negation. So this was what was the statement? P and Q. You take the negation, you get minus P or sorry, negation of Q. Pardon my language, not minus. Never say that. Okay, negation of P or negation of Q. Now negation of P is that Nitigi is not feeling cold or Nitigi is not hungry. That's your negation. That's the totally correct answer. I mean, there's nothing wrong with here. But can I say that if Nitigi is not feeling cold, can I imply that Nitigi is feeling hot or warm?
No, sir, we can't like this.
Sorry, I can't hear you. Nitigi, can you please mute your mic? Yeah,
No, sir, we can't write like that.
we cannot do that. Very good. So the reason why we can't do that because you don't know the real feeling. You just know that he's not feeling cold when you're negating that. That's all you know. So this implication, this logical implication is not going to turn out into this part always, except the mathematics. Forget about it. If you have a statement in English, simple English, just write in English. That's all. Okay, I don't want you to do anything except that. And you will get those kind of statements, not even in entrance exam, then maybe in real analysis in first semester. I mean, or you will get that. So this is the most important part that I want all of you guys to work on. So here are few statements. Negate them. Um, this is your homework. First question is the square. You guys are noting down, right? Nitig, that is clear, no?
It's clear now.
Good. I always find people, struggling with logic. I don't know why. So, just give me a 1 minute. I'm so sorry. Yeah. So there is a rational number whose square root is irrational. Can anyone tell me what is the statement of limit of a function? Anyone?
So can you repeat?
What is the statement of limit of a function? Note them down, and this is your homework, guys. And we are done with this. Just one part, necessary and sufficient condition.
Sir,
Yeah.
the third question and fifth question is not getting what saying.
Uh, if Q is odd, then a squared. Oh, I meant to say that if Q is odd, then it's a square is odd. Just give me. Why that pen is not working? Good. You guys are testing my punctuation and grammar. Good. Is it done, guys? Can I
Sir,
move on?
fifth. Sir, fifth.
Fifth. Fifth is for every epsilon greater than 0, there exists some delta greater than 0 for all x such that mod of x minus a less than delta, we have f of x minus f of a less than epsilon. This is the statement, and you have to negate it. Done, guys?
Yes, sir.
Cool. Now, moving on, I want to talk about necessary and sufficient condition. This is very small topic, but I think that you guys should know. So what does necessary and sufficient condition means? That when you talk about P implies Q or Q implies P, and P both way implication Q. Now think about the example that I gave you. My car is out of gas, then my car won't run. If my car is out of gas, then my car won't run. So to make Q happen, car won't run. Car is out of gas. To make this happen, this is a strong argument or this is a weak argument? What do you think? Is it okay? Let me ask this. It would be better and give you a clear picture. If your car is not running, can you specifically say that it is not running because you are out of gas? Can you always make that statement?
No.
You can't. Why?
No.
There might be another reason.
Good, very good. It might be another reason for because of that your car is not running. So this is not a strong argument. This is a weak argument. And for weak, we say that P is sufficient condition for Q. I mean, when someone says that okay, P is true, guys. When I tell you that okay, car is out of gas, that is sufficient condition. I don't have to think about anything. Okay, my car is out of gas. I can say my car won't run. That's all. What else has to do? Nothing, right? But when I say that my car won't run, and I want a specifically this one to be true, my car is out of gas, then I need to make a strong argument on Q that okay, it won't run, right? So this is a necessary condition to make this implication true, right? For which? For P. So when you have implication, P is sufficient for Q. Q is necessary for P. Now let me ask this. This is one of the very interesting questions. When I said that Q is necessary for P, why? I just said it. I mean the reason, but why do you think this is a strong argument, and why do you think that Q is necessary for P? Anyone? So guys, I don't know who said it, but someone said it now that if your Q is true, Nitik, yeah, go ahead. Okay,
I cannot think of anything.
no problem, no problem. It's really easy, but you're not thinking in that way. No problem, just we'll get there. So I'm saying that this is what you got it now, you all, that P is sufficient for Q. This is what you all got. I mean, this is sufficient. Somebody tell you, okay, my car is out of gas. You don't care about it. You can't want
Yes.
run. This is sufficient. But the point is that why Q is necessary for P. So you must be thinking that okay, there could be some other reason for which this is happening. I mean, your Q, which says that your car is not running, So there could be another reason. Somebody said it. I don't know who was she, and she said it that there could be another reason for which your car is not running. Of course, but that is necessary that this could be also the reason, na? That is necessary for me to say that okay, it is possible that my car is out of gas. That's why I'm saying that Q is not happening. It is possible. Look at the statement again. I'm saying that when you say that Q is necessary for P, so there could be other reason beside that P, right? X, Y, Z. I don't care about them. I really don't. I just care that because Q is necessary for P to make P happen, Q is necessary. Because can you say that your car is not running, and can you say that your car is out of gas? Think about it. Can you say that? You can. The point is that you can say that because if your car is not running and you're saying that your car is not out of gas, you can. But can you say that your car is not running and your car is out of gas? You can't say that, right? So for other reason, you just don't care about them. This is, we call it implicit assumption. When you will study again, we have aerial economics, there you will get implicit assumption thing, but forget about them. Just think that okay, Q is necessary for P, and why it is necessary, because P could be one of the reasons for which Q is true. That's all. So to make that P happen, you must hold a strong argument on Q. That's all I want to say about this. And when you have Y conditional, that means double implication.
So can we
Uh-huh. Go ahead. What's the question? I'm not able to
so
hear.
so I'm understanding it this way, that Q is necessary to Q has. Can you hear now?
Yeah, I can. Yeah, I can hear you.
So I think so. Q has to happen in order to make a judgment about P.
Yeah, right.
Is that what it's saying?
Yeah, yes. You're thinking the correct way. That's a very good.
So please unmute yourself.
I'm so sorry. What happened, guys? Did I lost my connection? Were you guys able to hear me? What I said about P double implication Q?
No, sir.
Okay. So okay. So I said that what what do you think P double implication Q means? P double implication Q is P implication Q intersection, or you can say that conjunction Q implication P. That's what you have. And I just told you that P implication Q, for which this part, P is basically a necessary, as P is basically a sufficient condition to make that Q happen. And for this part, P is here. I'm so sorry, I have written opposite way. Let me write it with, let me make the fresh argument. Can I break this as this? What is this? sorry, this is not an implication. This is really a wrong idea to write this way. Okay, can I write that? Guys,
Yeah, you need to say what are you writing?
yeah, so can I write this one? Guys, this is the basic definition of P double implication Q. I have just broken.
So we can see your screen.
So please start sharing the screen.
Oh my God. Oh God. What just happened? I'm so sorry, guys, for this terrible experience. Can you, I don't know. Yeah, can you, are you guys able to look at my screen now?
Yes, sir.
Hey, okay. Yeah, so let me repeat that again. Necessary and sufficient condition. You start with P implication Q. I said that P is sufficient condition to make that Q happen, but Q is necessary condition for P. So if you want to make sure that your P holds, you need to make sure that Q must hold a strong argument, that Q must have happened. Then you can say that, okay, P is going to have, P has happened. I gave you the example of car, gas. I can give you another example that, okay, I took an umbrella when it was raining. No, if you can say that, okay, if it will rain, then I'll come home by a taxi. That's your statement. So if you come home by a taxi, that's a necessary condition to make that happen. Okay, there was the rain, right? So Q must be necessary for P. That should be in your mind. Why? Because you can't say anything about P except the fact that if Q hasn't happened. If Q hasn't happened, you can't say anything about P. So to comment on P, you need to know that Q has happened or not. If Q has happened, then you can say, okay, Q, then P must have happened. Now coming on biconditional, P both ways implication Q, I can say biconditional. You can break down using the definition that P implies Q and Q implies P using the intersection, right? Now, because these two are equivalent, now I have just shown that P for this part is necessary condition for Q. And from here, you are saying P is, I'm so sorry. What did I written? I wrote opposite now. P is sufficient condition for Q and P is necessary condition. P is necessary condition for Q. So when you combine them, you get P is necessary and sufficient for both ways implication. For Q. So this is the result you get, guys. Any doubt here? Any question? I cannot see you guys, so let me. Yeah. Any question, guys? No? Okay. Now, let's take 5 minutes break and come back. You guys are exhausted, right? Can somebody talk what I'm saying? Okay. So can anyone tell me what is function? Guys, can anyone tell me what is function? No? Charna, what is function? I'm so sorry, you're looking at screen. Yeah.
Sir, we
Manvi?
can say function is a defined relation.
Go ahead. Sorry, I thought you wanted to speak. Yeah.
So we can say function is a relation between two sets.
Okay. Two sets. Jharna, what exactly were you saying?
That's what I said. It is a relation. It's a specific relation between two sets of numbers.
What do you mean by specific?
So like the domains, like all the domains should have their image. All the pre-images should have their image, and these criterions I'm talking about.
Okay. Simran? Simran, is she here?
Yes.
Yeah, what do you think function is?
Actually, it's a relation between two sets.
Okay. Nitikya?
So it's the same. I was thinking more in terms of x and y. So for any value x, it returns
Okay,
a
hold on.
value path.
I got it. You guys aren't clear about the concept. When you say relation, and when you say that you're defining function, you need to use the word unique. Why? Question is why? Why should I care about unique? A specific someone used it, right? That was the correct, definition. That a specific relation. So let me tell you why. Is this a function? And this is a function. Which one do you think is a function? Okay, let me make it more clear and precise. You go here. This is your x, this is your y. Start with 0, 1, 2, and so on. Start with 0, 1, 4, and so on. Now, what do you think? I have just mapped the first one into set format, and I have mapped the second one is also in the set format. Now, what do you think? Which one is unique?
So the first one is
The
one.
third one.
Why first one is unique? This is the first one. Wait, this is the second one. Why first one is unique? I mentioned 3 elements. Just ignore that. There could be another elements, but think about it. This should give you a clear picture. Guys, this is not unique. Okay. I don't know why you guys aren't answering that, but look at here. Your 1 by 4 and minus 1 by 4 both are going to the same number. How can you say that this is a unique relationship? Can you, what does unique mean? That one element is specifically related to another element. Let me repeat that. What does unique means or unique represents in relation terms? One element of a set A is related to, specifically related to, or uniquely related to just one element of another set B. That's what unique relation means. You understood? All of you. Guys, it's just definition. I mean, I don't know why this is hard for you. Can somebody confirm that you guys understood this one?
So I understood.
Good.
Understood.
Yeah, so unique means that an element of set A is related to an element of. Look at the article here, and I'm not saying multiple. Okay, set B. So if this is happening, then you can say that relation is function. Otherwise, you can't say that. Now, what do you mean by domain? So the domain is basically this set. Set of elements which are uniquely related. Range, set of elements which are directly related from unique, a specific element of another set. In human words, you don't have to any definition, barely anyone ask, but in human words, what do I mean to say? That when you write y equal to x squared, your domain is, or when nothing is mentioned, your domain is R, right? And your range is R positive. What do I mean when I say R positive? Does it include 0 or not?
Include 0.
It does. Good. And you can see the graph. That this is the graph that you get. It's simple. Now, the question is that what should be the method to, to find out domain and range? Right. So the idea is for
Excuse me,
domain.
sir.
Yeah.
Sir, in the two sets that you mentioned above, the first one is a function or not?
No, it's not. I did say that, right? It's not
Sir,
unique.
but
Uh-huh.
the every element has a unique image now. Like 1 by 4 has a unique image, root 3 by 2, and minus 1 by 4 has a unique image,
No,
root 3 by
actually, I'm so sorry that you thought that way. I made it incorrect arrow. I'm so sorry. I got it. I got your point. I made incorrect arrow. So this is where it is going. You got it. So when you put root 3 by 2, you will get two different elements.
Yes, sir.
Now you got it. I'm really sorry. I missed that point. Thank you for pointing out. All right. You can also think this other way. I mean, just make the graph. This was a circle, a unit circle, standard unit circle. So can you say that this is a function? I mean, the plus square root of 1 minus x squared is this this part, and negative part is this one. So can you say that this is a function? I mean, if you just make one horizontal line on this curve for 1x, how many y's you are getting? You're getting 2 y's. So can you say that this is uniquely related? Guys, why is this not clear? Anyone can tell me why this is not clear? Why this is confusing you? Guys, I've stopped. Can somebody talk? Okay, no one? Nitigya?
So what's the
No, the question is that is this point clear or not? That's what I'm saying.
so this
Yes,
is a
sir.
function, right? Circle.
Circle is not a function. Why do you think that this is a function?
So for every x, there is a value of y, which is part of this. So
Is that unique? Again, I'm asking that point. Is that unique?
No, so
Why is not unique? And see, the point is that, I mean, how do you define the unique relationship?
so because for every value of x, we are getting two different value of y.
Two different values y, right? So
yeah.
when you put actually 1 by 4, how many y you will get? From here you should get another y. That would be minus root 3 by 2, right? If I put no, my calculation is 1 by 2. It should be 1 by 2. Wait. Why am I lost? Yeah. So when you write 1 by 2, what would you get? You will get root 3 by 2 and you will get minus root 3 by 2. Can you say that 1 by 2 is uniquely related to any element in y? Okay. See here. I might have made incorrect argument earlier, and I accept the fact. Okay, and I'm so sorry, but yes, the point is that you take 0, you take 1 by 2, you take minus 1 by 2. Now, at 0, what would you get? 1 minus 1, right? So at one input, you're getting 2 output. How is that unique relationship? Just tell me that. Is that unique or not? It's not unique.
No.
Now, if at 1 by 2, if you put 1 by 2 here, you will get 1 minus 1 by 4. Yeah, plus minus y equal to plus minus root 3 by 2. Now, root 3 by 2 and minus root 3 by 2. Now, think about this again. Dipanshi asked this question. Yeah. Now, think about this again. Can you say that this is a unique relationship? Guys, can you say that this is unique? It's not. So that's all we need. Okay, if this is not a unique relationship, then this is not a function. I mean, you can check that. So yeah, this is y equal to plus minus under root of 1 minus x squared is not a function. If I say that y equal to 1 minus x squared is a function, okay, then I'm pretty clear about this, that this is why, because this is going to give you an unique relationship. This is going to be always give you y is always going to be positive, whatever x you will choose. So now you can say that, okay, whether I choose 0, 1 by 2 minus 1 by 2, I'll get from 0 I'll get 1, 1 by 2 I'll get root 3 by 2, and minus 1 by 2 I'll get root 3 by 2. Now we can say that, but you can't say that in earlier case. Why? Because you were getting negative number as well. From one input you were getting 2 output, so that is not a unique relationship. So to make that happen, you must have a uniquely related value, and this is a unique relationship. Sorry, yeah, this is minus 1 by 2 is uniquely related to root 3 by 2. That's totally fine. You are getting two different tags, the same output. That's totally fine. But for one input, you can't get 2 outputs. I hope it makes sense. Now, I was about to go on domain. Yeah. So, what do you think to find domain? What do you think we should do? So there are few criteria. In general, you look for where our field theory or real number system is not defined. So in our real number system, your denominator cannot be 0. Okay. The square root inside this will always take greater than equal to 0. I mean, the inputs in a square root should always be greater than equal to 0. Logarithm function, this should always be positive. Okay, these are 3 fundamentals, and anything else, yeah, exponential. So when you write x to the power m in general, so your x, I mean, you can't take x equal to 0 and m equal to 0. In general, we don't take it. Okay, we don't define them. So these are the few points, but in general, you will get denominator not equal to 0 or this or this. These are the fundamental things that we usually face when we have to find domain or something. Yeah, so this is a question that 2x upon 1 minus x squared. Fx equal to 2x upon 1 minus x squared. Now, if I ask you to find domain, what would you do? So this is a rational function. What is a rational function, guys? What is a rational function? Can anyone tell me? Simran, what do you think rational function is?
Ratio of two polynomial functions.
Sorry?
Ratio of two polynomial functions.
Yeah, ratio of 2 polynomial functions. So these 2 are polynomials, and here to find domain, your denominator should not be equal to 0. You write 1 minus x squared not equal to 0, and x squared not equal to 1, then x not equal to plus and minus 1, right? And otherwise, this is defined on a real number system. So your domain should be r minus 1. Okay, I hope this is clear. I mean, this is pretty easy. So let's write down some function and tell me the domain. And tell me the answers. Now, I mean, you'll have to do it now. Just give me a minute. I'll come back. Okay. Sorry. Nitik, you tell me the first one. How did you get real number?
So x square plus x plus 1 should be less than 0 for it to not be a, matlab, it should not include in the domain, but there's no value for it. It is lesser than 0. So
Why?
I think it should be all real numbers.
Yeah, no, I'm asking why.
So because x square plus x plus 1 should be greater than 0, then it will be defined.
Who is talking? I can't see that. Manavi, yeah. Wait. What just happened? You guys aren't able to see my screen, right? Guys, can you hear me?
Yes.
Okay. What just happened? I don't know. Yeah, got it. Just give me a second. Yeah. Yeah. So, how did you get the whole real numbers? Because I just want you to say it. I mean, it's just one word. Why do you think this is always positive for all real numbers?
So there is no root for the x square plus x plus 1, and
Yeah, because D is negative. I mean, that's why you are getting all the positives. So the property says, let me tell you this one. If you have ax squared plus bx plus 1, since this is a log, that means that x squared plus x plus 1 should be positive. It can't be 0 because it's a log. That's what our field theory decides in this current real number system. And to make that happen, your quadratic equation, the equation that you have, ax squared plus bx plus 1, okay, if a is positive and d is negative, then f of x, I mean the quadratic equation is always positive. So look at this. Your a is 1, which is positive. What is your d? Calculate d formula. D is b squared minus 4ac. So how do you do that? What is your b? b is 1. 1 square minus 4 into 1, that is minus 3. This is negative. If a is positive and b is negative, then f of x is going to be positive, right? So that means that this is always going to be positive. And since this is positive, I don't have to check anything. I mean, my x is defined on real number, then my domain is real number, right? This is my answer. What about second question? Tan x inside of log. What is the answer of this one? Subjit, can you tell me the answer? Who can tell me the answer of this question?
So it's r minus n pi, set of n pi where n is an integer.
Good. Who did it?
Just now.
Jana. Good. Good. Yeah, this is the domain, guys. How do you get it? You said that your tan x can't be 0 and tan x should be positive. So yeah, so you did not include the negative part, right? So where do you think tan is negative? That is also that you'll have to exclude. I think Jana, you missed that point. So tan is positive in this first quadrant, right? And tan is positive in third quadrant. Now, to make tan x 0, your sin x is going to be 0. So sin x is 0 when your x is in the form of n pi. So this cannot be in domain because that will make tan x 0. So I need to exclude this one first. Now, tan x is positive. Now, where do you think this is positive? 0 to 0 excluded to pi by 2. What do you mean by pi by 2? Can you take the open interval or the closed interval? This is a question, guys. Can you take open interval or the closed interval?
So open.
So open.
Open interval, right? Why? Because of cos, you can't. Because of cos function in the denominator, you can't say that this is going to take the pi by 2. And even if you do that, that will make denominator 0, right? So that's why we aren't taking. And what is this? This is pi, and this is 3 pi by 2. So I can't include pi, I can't include 3 by pi. So union pi comma 3 by pi 2. Now, how do I write this in general format? I write this 0 comma 2n minus 1 into pi by 2 union n pi into 2n plus 1 into pi by 2, where n belongs to integer. Is this true or not for all n? Guys, this is the domain that you have got, right? So my n pi got excluded in this one when I write 0 and n pi with open interval. So I don't have to care about that. I just have to care about the positivity part. And this is the positivity part where I'm saying that tan x is positive. And where is tan x positive? Tan x is positive in first quadrant and third quadrant. How do I first write in terms of in between 0 to 2 pi? So I written 0 comma pi by 2 union pi comma 3 pi by 2. And then I had to generalize them. Why? Because I'm taking all the integers to in the consideration, right? Because I am on real number system. So in general, how do I write this? I write this 0 comma 2n minus 1 into pi by 2 union n pi comma 2n plus 1 into pi by 2. Is that clear? Is that clear?
Yes, I got it.
So what is the third question? 3x upon x minus 5. This is pretty easy. So I want Gulfisha to answer this. I think Kiran is here, right? Yeah. Kiran, can you answer this one?
Yes, sir.
Yeah. What would be the domain?
So domain is a real number minus 5.
Yeah, this is pretty simple. You just take the denominator, make it non-zero, and just exclude that point. I'm not gonna solve it. This one, Gulfisha, tell me that this one, x square plus 5, and this is also pretty easy. What did you get? What is the domain?
So इस denominator is greater than 0 अपना, तो ये are positive numbers.
No,
Domain.
no. Simran? Simran. Shiva is not here, I guess, today. Simran, what did you solve this?
No.
Okay. Okay. Who else is here? Dipanshi? Dipanshi is not here? Okay. Jharna, I think she. Tell me, Jharna, what is the answer?
So r minus 1.
Good.
So minus 1, sorry.
Yeah, I got it. Understand. And what was the last question? Tan x plus cos x divided by log tan x square root. This is a tough one. So earlier we solved for log tan x. And here the domain was 0, 2n minus 1 pi by 2 union n pi, 2n plus 1 into pi by 2. Now, this also needs to be greater than equal to 0. But you know that log graph goes something like this. So when do you think this is going to be, sorry, not equal to 0? Because it's in denominator. So it should be strictly positive. And to make that happen, you need to solve for log tan x greater than 1. Now, tan x should be greater than equal to e to the power x. Right? So for what value of x can I say that tan x is positive? Tan x is greater than e to the power x. So if I take x equal to e to the power x, tan inverse arc tan e to the power x, where e to the power x is going to range in between, it is always positive. So 0 to infinity, right? Now for 0 to infinity, for this value, where exactly am I? This is positive, this is positive, and I am going to get 0 to infinity here and here. So here, whatever x you have got, for that value, you are going to get actually Wait, tan x is greater than e to the power x. If this is 0 and 0, this is going to be 0, and then it will start x e to the power x. Yeah. So, guys, the inequality is tan x e to the power x, right? And for this inequality, you need to check the rate of change. Do you guys know differentiation? I'm sure, I mean, I don't know you guys know that or not, but for this problem, just know that we need to differentiate, and for differentiation, you get sec square x rate of change, and here the rate of change for e to the power x is e to the power x. Now tell me that if your x is positive, I mean always positive, then what can you say about this inequality? If your x, let me repeat that, if your x is positive, what can you say about this inequality? Given that I have mentioned the rate of change. Response, guys. What can you comment on inequality? When I say inequality, I mean these. When I say that x is positive, which one is going to grow faster?
Ex.
E to the power x, right? And why do you think e to the power x is going to be faster?
It's cos, right? In the rate of change, it's 1 upon cos square x, and cos value changes, but it oscillates. As ex is a positive.
So one thing you should always keep in mind, where is my pen? Yeah. One thing you should always keep in mind that exponentials have higher rate of change than trig functions, right? Always keep that in mind. So when I say that tan x is greater than e to the power x, there is no such x for which I can say that, okay, for this x, tan x is going to be greater than e to the power x. There's nothing as such. I mean, you can solve that. I think we should get 5. So this conclusion is coming out from rate of change perspective. So no matter your what rate of change is, this is always going to bother you in terms of the value. So you start making the graph, and you start, or your tan x start making the graph. This is the graph of tan x, right? So at when tan x take 45 daily, it gets 1, right? So this is actually 1. And this is this. And at pi by 4, you get e to the power pi by 4. That is always going to be greater than that 1, right? I mean, you can think of logically, what is the value of e? The value of e is 2.7 something, right? And you are taking the power of that number. So you are going to get the value more than 1. So can you say that this is going to, cross e to the power x at any point? Can you say that? You can't,
No.
right? So that's why there is no such value for this. Log tan x is going to greater than 0. That's why I mean square root of this. So I think this should be 5. right? Okay, any doubt, guys? I
Will
can't
we
see you
encounter
guys'
more
faces.
trigonometric function?
No, in exams, I don't know. I mean, it depends.
Yes.
But you get logarithm. You get log. I don't know. You guys are exhausted because I am. I'm totally burned out. I woke up in the morning and first thing I actually took your lecture. And now I have a meeting to attend. So if you guys have any question, you can ask right now. Otherwise, I'll just end the meeting. I'll just run. I'll just also stop the meeting.